have three people. Okay. Hi, everyone. Welcome and thank you for joining. And welcome to another weekly circuit session with today we have the guests. We have our guests from Pharos Network, and we also have the guests from HackQuest. And so on my end is 5 p.m. in the evening, UTC plus one Nigerian time. So I'll say good evening to everyone, and thank you for joining once again. This is the session two, or should I say the second session from our previous session with Pharos Network, where we'll be talking about Pharos Network and also talk about the current builders based happening on Pharos Network. So I'm just going to go ahead and introduce my speakers for today. So Janesh, over to you. Janesh is the developer for Pharos Network. So I'm just going to go ahead and do the intro. Janesh.
Hey, hi everyone. It's really great to have you guys back again. So, as you all know, I'm the lead development engineer at Pharos. So, I take care of all the infra, all the developers building on Pharos, and everything that is happening on chain. I always take care of that. So, you can always reach out to me if you want to know something new about Pharos, want to explore the whole technical architecture and everything. Talking about today's agenda for everyone, the plan is like we are going to go a little bit deeper on the overall tech of Pharos, how it actually is. So you'll guys have a lot of new questions in your mind about everything that we discussed last time. So we are going to go much detailed information about Pharos network, about its architecture and everything, and then we're going to see how easy it is to build on Pharos. Like if you are an Ethereum builder, if you're building on Ethereum and Solidity for a very long time, I'll just show you that how you can deploy a contract in just 1 or 2 minutes on Pharos. That's how simple it's gonna be. No changes, no big changes you have to do. You can just actually deploy your contracts without any issues. You don't have to change hard at Foundry or anything. You just need the chain details and you are all set to build projects on Pharos.
Oh, okay. That's fantastic. Thank you for going over the agenda. That was actually really fantastic. And I think from our last session, we were able to talk about how Ferrell is able to scale up to, was it 20,000 or 60,000 transactions per second? So today is going to be a really, really packed session. And before we go into that, I should introduce John. John is the developer for HackQuest. And for this session, we are partnering with HackQuest, and I'm just going to give it to John to kind of like talk about our quest and basically like an intro. So, hi, John.
Hi, AC. Hi, everyone. It's a pleasure to be here once again. And I really appreciate the opportunity to work with you guys once again. It's been awesome working with the East Nigeria team and getting to meet you guys also in person. It was awesome doing everything we've done together. And for this project we're working on too, I really appreciate you guys' response, tenacity, and all. So quickly to talk about HackQuest. Sorry, give me a second.
No problem. It's no problem at all. Okay. While we're waiting for John, I think I'm just going to take it from here. I'm just going to introduce. Oh, welcome back, John.
Yeah, sorry about that.
No problem.
So to quickly draw an introduction of HackQuest, I'll share my screen and just run through HackQuest. So this guy, this guy. Um, is my screen visible?
Oh, okay. Um, yeah, it's visible now.
All right, yeah, thank you. So, HackQuest is a Web3 learning platform. For those who don't know, we offer
Um, I don't know if it's on my end, but I think I stopped hearing John.
You can't hear me?
Oh yeah, yeah, visible.
Okay. Yeah, so the self-paced learning model of HackQuest allows anyone to go from 0 to 1. And aside from learning, we also host hackathons on the HackQuest platform where anyone can join and build projects on any of our live hackathons going on HackQuest platform. Right now, most notable of them is the Pharos Hackathon, which we're working on currently, the project that we're currently talking about. And then we also host co-learning camps where we'll do virtual boot camps with communities. We partner with local communities and universities to host these boot camps across the world. And we also have a system where um, faucet system where developers can get testnet tokens to test and deploy and test their smart contracts that they're working on. And then aside from all of this, HackQuest also offers we also partner with ecosystems to host ecosystem tracks where you learn and get certified by the ecosystem they issue certificates that is recognized by the ecosystem. And then back to the hackathon where we're talking about the Pharos hackathon. It's 7 days to go for the hackathon to end. And during this 7 days and 21 hours, anyone can build and deploy anything. Now, a quick run through of the platform for the Pharos Hackathon. We have the prizes. Is the prize tab where you get a breakdown of the prizes and judging criteria. Then you have the schedule, which where you get IRL events that will be happening during the course of this hackathon. And then there's resources where you find useful resources to help you build and deploy on Pharos. Then we have Idea Bank where if you don't have any idea of what to build or you're feeling like burnt out to come up with any idea, you can just run through our idea bank to pick any of the projects here, build and deploy. And then for other information where you get our community partners, judges, and mentors for this particular hackathon. And then you can also check out the project gallery where you'll be able to get idea on other projects that you can pick out from to build for the Pharos hackathon. A project gallery is like a repository of all our projects that have been submitted for the Pharos hackathon, where you can just get ideas from there to build what you want to build. So that's a quick run through of the HackQuest platform.
Sure.
Thank you.
Okay. Thank you very much for that. And it's actually our honor to partner with HackQuest. And we partnered with HackQuest earlier on the EduChain hackathon. So HackQuest is a very, very good partner for Ethereum Nigeria. And I think now it's time to hand over the mic to Janesh. Thank you once again for taking this session. And I know for the last session, we already went over what the Pharos Network is, but if you could give us like a brief run through before we get down to the building, that would be wonderful.
Sure. So today it's going to be more detailed and comprehensive, as I told you last time. Before on the last call, I just wanted to set a tone about Pharos, like what actually Pharos is. But today we're going to do a deep dive, and it's actually not really difficult to build and deploy on Pharos. It's same as you do it on Ethereum. So without further ado, let me get started with everything.
Okay.
So I hope my screen is visible.
Oh
Yeah.
yeah, it's not.
So, so as you can see, today we are going to do a very much deep dive into the architecture and what are the possibilities that you can see on the innovation side of how Pharos is going to evolve in future, how it's going to tackle most of the complicated situations that current blockchains are struggling with. I'll just zoom in it for you so that you can see it clearly. So as we discussed last time, Pharos Network is a high performance modular layer one blockchain, and it supports the next generation blockchain execution, consensus, customization, with its 50 kTps, 2 gigahertz throughput, and parallelization, which is degree of 5. We'll explore about what is degree of parallelization, why it's 5, and everything. And it's the highest among all EVM compatible chains at the moment right now. So without further ado, let's take a deep dive into the Pharos network architecture. Let's see its consensus mechanism, its execution model, storage innovation, pipeline efficiency, and our interesting SPN framework. So when we talk about the network architecture, the stack generally looks something like this. It has a network layer, a consensus layer, execution layer, a settlement layer, a data availability and a storage layer, and an interesting addition of spatial processing networks. It seems quite a normal, similar to what we see in other blockchains, but things really gets try to change or evolve at each level, because with each level we have built it from scratch. It's not a fork from everyone else, like it's not a Cosmos fork, it's not something we are building like a fork of EVML2s or something like that. It's completely new design, revamped, just to tackle all the challenges that we are facing right now with the blockchains when it comes to real world utility. So at our network layer, in simple terms, it uses an optimized P2P gossip protocol for low latency messaging, and the network layer supports the cross SPN communication. So this is just an overview. We are going to do a deep dive into the network layer just right now. So with the network
Okay,
layer,
I'm sorry.
yeah.
I think I really want this session to be really hands-on. So if you could like go over the layers again, that would be fantastic.
So as I told you, the development is not that much difficult. It will hardly take us 10-20 minutes for development and writing contract. So it will be a very short session. That's why I'm explaining about the architecture. Do you want me to
Okay.
just right away go to the development? Because it's just going to take 10 minutes for us for the development.
Oh, no, it was more like you were explaining the layers. So if you
Yeah.
like go over the layers again, so that people can actually get to understand it.
Okay. Yeah. So I'll go by the layers again. So as I told you, it's very similar to what we see in other blockchains. The new addition is SPN networks. I'm going to discuss in detail about SPNs as well. And I'm going to go layer by layer in detail so that nobody faces any confusion. So first we're going to discuss about the network layer. It is a P2P gossip protocol, and it manages the cross SPN communication. It manages all the communication that happens on the SPL side of the things. Talking about in detail about the network layer, I'm going to come down here. The networking layer, it handles all the networking as I told you, and the system implements an adaptive bandwidth allocation management based on network load for efficient transaction and data propagation. So what we actually mean by this is, let's suppose we have a high frequency trading competition going on, we have a NFT trading happening, NFT sale is happening, or there is like a, like a esports competition going on. Let's say a game like Valorant, Call of Duty, Counter Strike is running on blockchain, and there is a huge global competition going on right now. Imagine this kind of situation on a blockchain. Network congestion, people are really frustrated because of network. The ping is really high. The game is not playable at all. What will happen if we do all these things on Pharos network? So at Pharos network, when such kind of situation is happening, most of the resources of the blockchain will be diverted just to cater this particular esports competition or a game or even an NFT competition or NFT sale or a high frequency trading is happening. So when we come to real world scenarios, the bandwidth allocation is managed something like this. It's not like every protocol is getting same kind of allocation. It dynamically adjusts everything, and the networking layer is responsible for this thing. So network layer figure out that on which side of the chain or which protocol actually needs the support of validators to validate the transaction, or where we actually need the resources to be diverted to. So all the CPU, RAM, storage, everything will be diverted to that part of the chain. This seems really interesting, but this is how we are going to do it. So we are going to discuss more about other layers to give you more clarity on how we are making it possible. I hope everyone is clear with the networking layer, like what it actually does. So it adaptively allocates bandwidth of the network depending upon the network situation or requirement. So it can efficiently handle all the transactions and data propagations with high speeds under stress. As you see, like high speeds under stress, it's like no one will face any problem while they are buying their NFTs when there is a big NFT sale happening. Anyone can just go and click, and there will be no network congestion in such situations. This will be really interesting for people who have seen network congestions on chains like Solana and Ethereum during NFT sales, or even NFT trading, DeFi trading, and building games. Gonna be really interesting here. So coming back to the consensus layer, how we are making it possible with the consensus. Obviously, the network layer has to be supported by the consensus layer, right? So at the consensus layer, we have implemented an adaptive asynchronous BFT consensus protocol, and it reduces transaction ordering bias and improves validator efficiency. Let's go in detail. So at the consensus level, as I told you about, it does asynchronous execution. What do I actually mean by asynchronous execution? So here, it doesn't matter who is proposing the block. Multiple validators can propose multiple blocks at the same time. So unlike classical BFT that requires a fixed leader role and round based communication, you see at Solana there is an epoch model. So at epoch model there is a round based communication. So every time an epoch has to be proposed, a consensus has to be reached, and then the block is validated. It's very tedious. It's very time consuming. And if we talk about leader based role, fixed leader based role, there always a babe and grandpa mechanism, which we can see on the primitive side of the things. Like there's always a multiple validators coming together, then reaching a consensus, and then actually validating a block. So one block at a time. But here at Pharos, as I told you, multiple validators to propose, to validate, and commit transactions concurrently in parallel. So this significantly reduces the bottleneck caused by leaders election. We don't have to waste time on electing a leader. We can just directly see multiple blocks coming up, and we can approve them with the Byzantine fault tolerance. It also implements dynamic transaction ordering mechanism to ensure fairness, reduce block construction bias, and supports consistent global ordering even during high network churn. So as I told you about, during even high network churns, this is possible to do it, and that's how it's much better to do it. I mean, most of the validators can validate the block and the activities and the transactions happening for that one single NFT sale, and rest of them can focus on other side of the network. So with more number of validators, we are not just going to decentralize the network. Theoretically, we can achieve 500 kTps. That sounds really crazy right now, but we are going to see it how. So if we keep improving our consensus mechanism, multiple validators can propose, and theoretically, we can achieve 500 kTps. So that's really crazy numbers in terms of what we see on the reality side. But it is always possible with increasing number of validators. But this is not possible with other chains at the moment, because the more you add the validators, the more slower the network will get. because it will get more difficult to elect a leader or have a round robin based model or have a like a, as I told you, round based model or fixed leader model. So when we have more leaders to select, it takes more time to do it. That's why in many chains the active number of validators is fixed. If you take a look at Cosmos, in Cosmos you have to really restrict the active number of validators. You cannot go beyond certain number of active validators. So this is something that is restricting the blockchain. But we want to grow with the growing number of validators. So we are always welcome for validators to come and validate on Pharos. Key features as I talk to about is like asynchronous execution, dynamic transaction ordering, fast path execution, leader rotation, and voting optimization. I hope everyone is really enjoying this new sort of an information. I believe there will be questions for everyone. So once I'll go through everything, we can take your questions regarding the architecture in detail.
Yes,
After
yes.
consensus, after consensus, execution layer comes into the picture because what will you be consenting about? Obviously, you need to execute something to get it through the consensus layer. So when we talk about our execution layer, it's also again an interesting picture coming up. So Pharos has integrated a dual VM environment. But here the interesting part is we are not like Substrate or Polkadot where we have a very different implementation of EVM and developers face a lot of problem while developing on-chain. I have worked with Polkadot based ecosystem and developers face a lot of problems because they have to work on a different kind of a hard hat, different kind of a foundry version which is specifically customized for that chain. So that's very problematic and cumbersome. Here we are fully EVM compatible and we can have even more gas limit. So we can exceed the gas limits and add more gas limits. So that's why it's 2 gigagas per second. So that's why we have more gas limits in the picture. So it's fully EVM compatible. But to have all the developers build on Pharos, we have WASM into the picture with LLVM based execution engine. I'm going to talk about what is LLVM based execution engine. It also supports parallel transaction execution, optimistic execution, and smart access list inferring. Let's go deep into this, how the execution layer looks like. So at the core of Pharos execution model is its execution engine that offers dual VM environment, EVM plus WASM, for developer flexibility. It combines LLVM based intermediate representation translation. So what happens here? Let me go a little bit deeper. LLVM is low level virtual machine based intermediate representation. What really happens is if you want to write your script in Python, Java, JavaScript, Rust, Golang, C, C Sharp, you can write your code on chain in any programming language. By I mean any programming language, I mean any programming language. And it's gonna be converted into WASM bytecode through our IR. So our IR will translate the code for the virtual machine, and you don't have to worry about what programming language you are coding or building on. So once we hit mainnet, you can write SVM, that is Solana contracts. You can write move based contracts. You can build ZK easily. You can write with any code that you want, and it will be converted with WASM bytecode and with spectacular parallel processing. Why I'm saying spectacular parallel processing? Because our execution engine can also handle parallel processing. One side there is EVM execution, and other side other programming languages are executed at the same time. So you don't have to worry about transactions getting stuck, or if you are building with other programming languages, will there be a very long time that you have to face. So let me tell you honestly, if you are building a high performance protocol that uses Rust and Golang as a backend, but you want to build it on chain, that's possible with Pharos. And that's what we are looking for. EVM, I know EVM is a little bit slower on the processing side and has its own limitations because it has taken the inspiration from an scripting language of JavaScript. But at Rust and Golang, we know it's a system language, so you can design high performance systems. And all this can be designed on our Pharos network. So you don't have to worry about. It also applies several performance optimizations such as opcode fusion. So when we talk about our opcode, it's much more efficient than the currently available opcodes of all the EVMs in the market right now. It has the registration, promotion, and obviously, as I told you about the execution. These optimizations allow smart contracts to be executed in parallel while maintaining deterministic results. I hope everyone is clear with the first paragraph. Now coming to the second part, to increase the execution efficiency, we introduce smart access list inferring, a method that can statically or dynamically infer with state entries a contract will access. Using SALI, the execution engine can group transactions with disjoint states, access patterns, and execute them in parallel without any fear of conflict. So it can actually group the transactions. That doesn't have to do with any single state. So multiple states with this, which have no interrelation with each other, can be parallelly executed. With this, we are reducing the conflict of any fears that are happening while doing parallel transactions. So transactions will not compete with each other. Instead, they will be parallelly processed on the network. And it also preloads contract state objects for faster execution. So what it does, that it actually preloads the contract state and it keep it in a RAM. So we are doing RAM optimization here. So all the objects, all the functions are preloaded. So it's very easy and quickly to access all these things on the execution side of things. So this is something really new that we have done as an innovation that can preload the contract state, because otherwise there always a new state that is proposed, a newer object is introduced, so it takes a lot of time to make it possible on chain. We are making it as fast as possible so that nobody has to fear about if they are on chain or off chain. It's going to be same experience as you do things off chain. As I told you, it supports for Pharos WASM, a specialized WASM runtime with deterministic high speed execution and native support for languages like Rust and Go. I mean, it goes beyond that. This is just for example. So this makes it possible, as I told you, to build high performance portable dApps and AI models directly on chain. The key features
Okay.
are optimistic execution and transaction grouping, smart access list inferring, multi-VM smart contract support. I know that it is very much new for all of you to process, but I really hope if you are making some notes down there on your diaries on your computers, because you are going to learn a lot of new things here that you have not seen in the Web3 space right now. Then talking about a settlement layer, since it's an L1, all settlements happen on the L1. We are not an L2, we are not an L3 where the settlements happen somewhere else. So it simply implements validator staking mechanism for shared security, and it also ensures fast settlement of transactions across all execution environments. As I told you, there are multiple execution environments. One is EVM, another one is WASM, so you don't have to worry about it. If I go a little deeper on the storage side, is it you can see that Pharos storage is scalable. So we are now coming up to the storage part. But before coming to the storage part, I'll just give you a small overview of the data availability and storage layer. There's nothing new on the settlement side. It's just a validator staking model. So I'm not going to bore you with that.
Okay.
So the data availability and storage layer is again a new storage that we have implemented. We are not copying what Ethereum already has. We are innovating because we know like it's not scalable. So that's why we have designed our own storage model, which is much more high performance and multi-version. So our storage model can actually handle 1 billion active wallet addresses, which is not possible on other EVM chains. Imagine 1 billion active wallet addresses, and it can go even beyond that. It also uses ADSS push and delta encoding to minimize disk input out. What is this? Let's take a.
Okay.
I really hope that you are enjoying this new information coming towards you because we are not like any other L2, L1 in the market right now. Faro
Okay. I
store is a
think
very, yeah,
sorry for cutting you short. I'm so sorry for that. I think that is a lot of information. So, like, will you be willing to share this documentation with the community so that we can always go back and look at it from time to time?
yeah. So we are going to publish this article in 1 or 2 days for everyone to access, and they can just access right away from our. But it's just that like you are getting like all the case studies and information from myself, so it will be much better easier to understand because if someone will read, it will get confused. So it's better we do it here right now.
Oh yeah, true. That's very true. So carry on.
Yeah. So when we talk about Faro storage, it's scalable high performance blockchain storage that actually eliminates the state bloating. So like a lot of information coming up on the network gets bloated. It takes time to manage all the input outputs that are happening. So when we are in Web 2, there's a faster input output that is happening on the server side. But in blockchain, what really happens is when new information is coming up, the networks get bloated. We don't want bloating. We want smoother transactions happening, input outputs happening. So that's why we innovated the storage in the blockchains right now. So the data engine is built for versioned state storage. So it eliminates efficiency found in the Merkle Patricia tree-based system. So what happens in Merkle trees is basically whenever someone loses out on the network, they have to again start and trace back the whole Merkle tree until they reach the current state. So they have to always start with zero. If any validator or any model or anyone loses out on the network, if they fall back. So it takes a lot of processing for them to come back and a lot of time they take to reach the uptime. But this is something different what we have done. So here we have delta encoded multi-version Merkle tree. So what I mean by delta encoded multi-version Merkle tree, so it basically a log structured version page storage. So basically there is a log maintained for what is happening on the storage side. And with every new update, every new Merkle tree is input, there is a version that is being stored on the storage side. So anyone who wants to come back to the network and make the uptime really fast, they can just simply do that with the latest version or the latest. They can check the log, they can hit the latest version, and they are up. So with this, it enables fast state retrieval and parallel Merkleization and reduces the storage overhead by 80%. So every time they don't have to go buy the storage again and again, again and again. They can just simply hit the latest version and they are up. So this is all compared to the Ethereum's try model. So that's why even if you add more layer twos in the Ethereum network, you will not be able to scale because they will still be relying on the storage of Ethereum.
Okay.
So by storing only modified state deltas and indexing them with version-based addressing, Pharos store drastically reduces write amplification and achieves up to 15.8 times improvement in input output. So you can imagine like we are making the storage much more efficient 16 times. So we don't need any AVS model to scale like Ethereum. We don't need L2s. We don't need anything to scale ourselves because we re-innovated the storage that is there right now. And obviously, since we have designed it, so we will keep on improving this storage model even further down the line because we have the control ourselves. We are not forking it from any other chain of any other model. So it's completely modern and upgradable. So you see like how we are doing parallelization and even able to upgrade our chain with the growing demand. So if the demand increases, we'll increase our efficiency and innovation. So this system also supports efficient proof generation for light clients and storage tiering for cold/hot data segregation. So with this, we can actually segregate the cold and hot data as well. Key features, as I told you about, are delta encoded multi-version Merkle tree, lock structured versioned page storage, light SPN asset transfer protocol. So now later we'll discuss about the SPN, but with this we can have better communication among all the SPNs in the network. We'll come later to the SPN part, but let's just go back and see what we are doing on the pipelining side. Like with everything, we need a new pipeline. Since we have our own storage, we have our own network, we have our own execution engine, then obviously we need a pipeline to make this all possible. So it's very simple. At Pharos, it's a multi-stage parallel execution engine. It eliminates the bottleneck as we discussed. So we optimize the CPU, disk input, output, and networking by enabling execution, merkleization, state finalization in concurrent pipelines. So there will be multiple pipelines running at the same time. This is not really what you see with other blockchains. So in the pipeline, there is only one thing happening at one particular time. But here there are concurrent pipelines running in the network, which reducing idle time and improving resource utilization. Like when you put a transaction on chain, you have to sit for it to get processed. But here it is actually not the case because even if there is a high network load, your transaction is always being executed in parallel. So you don't have to sit as an ideal person. You don't have to worry about check the explorer again and again. You just have to sit and see, get it done. So at the pipelining stage, there's always a block staging where the block is being there proposed. Then there is a dynamic resource allocation. As I told you about, it actually the pipeline actually sees where the resource allocation should be done, on which part of the blockchain the resource allocation is much needed. And then there is a flexible finality mechanism. So it implements ordering transaction block finality at different layers. So they are not competing for each other. So it will dynamically evolve. So each pipeline stage can dynamically allocate resources based on throughput demand, and flexible finality layers allowing dApps and clients to retrieve early information of transactions, ordering and execution results even before full block finality. This is especially critical for high performance trading, DeFi, and real time use cases. As I told you about AI, gaming, trading, everything is done in real time. With its adaptive scheduler and efficient resource orchestration, Pharos pipelining can reach up to 200 kTps using 64 core pipelines. So if we improve our CPU or increase the CPU count with 64 cores, currently the model is running on 16 core. At mainnet, we're planning to go 32 cores. With 32 cores, we are able to reach around 50 and even beyond that TPS. But if we double our CPU count from 32 to 64, you can actually see 200 kTps possible in real time. This is not something I'm talking about theoretical, because if I talk about theory, in theory we can go 500 kTps, but here we can go in real time 200 kTps. And I believe 200 kTps is much more sufficient what we see as compared to Visa and MasterCard. Visa and MasterCard are processing around 300K transactions globally in a second when there is a
Wow.
high test, uh, high frequency happening. Like all of the people are doing transactions and all of the financial institutions are doing transactions. So it's very high, like it is going to be 300K to 400K in 1 second. So we are very close to hitting those numbers on the real time. And it achieves 32% lower latency than standard blockchain pipelining models. So now it's time to take a look at spatial processing network frameworks. So SPNs enable custom blockchain execution layers with configurable consensus model. An SPN operates semi-independently but share the security and data with the main network. So you can see it as a subnet on the Pharos, but with your own customization. So you can do application specific execution environments that can integrate tightly with Pharos mainnet. A good example to give you here is, let's suppose a bank wants to come on chain. Do they come as a protocol or a dApp just to tokenize their fund? But here they can have more control and more flexibility because they can set up their own execution engine. Imagine all the banks communicating on the
Mhm.
chain level and doing transactions on chain. You can make your own payment transactions on chain because all the banks, all the payment partners are communicating across SPN. With this kind of a finality, transaction speeds, and everything that Pharos is providing, SPNs can have their own execution engine, as I told you about, and their own consensus. So banks doesn't really have to think about, oh, we need EVM, we need Rust, we need this, we need that. They can just deploy their own execution engine, have their own consensus, whatever they like, and they are ready to set on chain. So currently we have a Swift based mechanism where all the banks communicate on the global level. So Swift is basically a nomenclature given for the network on which they are communicating. So they hop from one bank to another. But here will they will hit near instant finality. I'll just take a little bit of your time in explaining what is Swift based mechanism. Let's say I'm sitting in Vietnam right now. I want to make a transaction in Europe or US. I'll use my own bank to do the transaction. So what will happen is my bank will actually make a call to other bank that is there in Europe. They will just update their order book on the transaction side for me, but the actual settlement happens little late. So you will see the transaction is done for you, but in actual the transaction is still sitting and it will take up to 3 to 4 to 5 days or even 7 to 10 days to actually get the settlement done. So this is how slow the network or the current chain is for banking systems. With this, they can just communicate with each other on the SPN network and they are all set. They don't have to look for a local banking partner in which region it is or that. They can just do the storage communication with Pharos storage, as I told you about, and as I mentioned earlier, light SPN asset transfer protocol. So with light, it's not going to be too heavy that they have to look region wise what's happening. They can instantly do that on our SPN network and with storage and everything. So it's done. I send you money, you will get it in your bank. It's not something on chain, you will get it in your bank, but through a payment channel that is being set up on chain. So once it's set up on chain, it's possible to do that. This is something really new that you are seeing right now or hearing right now, which I believe you haven't seen earlier on the blockchains. It's very easy to set up the SPN. It's going to be live on the mainnet. It has a SPN architecture. It has a manager that manages the life cycle, registry, and governance. It has an adapter that setups the cross SPN communication and message verification, allows validator and restaking and shared validator security. So allow validator to restake assets in multiple SPNs. So SPNs are ideal for compute intensive tasks like zkML proofs, secure multi-party communications. All the banks can securely communicate with each other that they do off-chain. AI model training, DeFi derivatives. They support forced inclusion and escape hatches, ensuring censorship resilient and user anonymity. So users can stay anonymous and it is censorship resilient. So this is something banks actually provide, but they can also get it on chain. So you don't have to worry about what's happening on chain. SPNs also interact via a cross SPN interoperability protocol, as I told you about. It enables atomic execution. This is going to be a little bit more, but I believe you all must have understood like restaking happens here, so it's nothing new. So cross SPN interoperability, messaging is there, censorship resilience is there, and then interoperability and cross-chain communication. So with all this mesh network, SPN to SPN communication, external block communication is much more easier. Even like talking to other blockchains is gonna be much more easier. So that's what we are trying to do at Pharos. Key features: cross-chain messaging, cross-chain SPN data signatures, multi-VM smart contract interaction. So everything is possible on Pharos, whether it's gaming, AI, RWA, DeFi, everything. I really hope that you have a lot of interesting questions for me today to go through.
Yeah, okay.
This is
And
all
keep
about
track of the live
Pharos.
stream. I'm keeping track of the live stream so that I don't miss any question.
So you see, that's why I skipped this particular session for our today's session, because this is going to take a lot of time to consume all these things. A lot of mental bandwidth is required for them to process everything. That's why last session was just an intro to get them warm up about Pharaohs. And today we went a little bit deeper onto the overall architecture. I can again take specific sessions on each layer separately because each layer also gets more and more detailed with time. So it's going to take a lot of time to actually understand what's happening behind the picture because everything is new for everyone. So I hope everyone is clear at the moment,
Yeah, I
and
believe
then
they
we
are.
can,
Yes.
yeah. So right now we can just see how easy it is for people to deploy contracts. I'm not going to do any fancy coding or anything. I'm just going to show you how easy to just take up a contract from OpenZeppelin, the most popular contract library for EVM developers, and deploy it on Pharos. Let me just switch my screen. So what I'm showing you right now is a DevNet onboarding guide. Currently, Pharos Network is on DevNet, and in couple of weeks we are going to be on testnet. So this is just the network details. So you can easily set up a wallet address, EVM compatible wallet address. You can just hit your MetaMask and easily add Pharos to the network, and you're all set. You're all set with your existing wallet address. Once you're all set with this, you can start deploying the contracts very easily. I'm going to show it how. You don't have to change anything, you don't have to do anything. Let's just take me to you to the wizard open source or open Zeppelin. You can see there are a couple of pre-built contracts for us here. Okay, so I have a my token. I'll keep call it my token 20, mtk 20. and I'm going to make it mintable, burnable. I'm just taking a standard open Zeppelin contract. This is not something what you like specifically built for Pharos or something like that. It's a very generic ERC20 contract. Okay. I'm now just going to open it in Remix. I simply open this up in my Remix. So my Remix is open. I'll do nothing right now. I'll just simply compile the contract first. So my compilation is done. I'll go to deploy. Okay. See, I'm doing nothing right now. I'm making it so easy for you. You don't have to do anything if you're building in Ethereum or anything. You can deploy
Okay.
any contract easily. I'll just ask it to inject the provider from my MetaMask. As I told you, I just put it the details. You can see the Pharos chain ID. So it picked my wallet. It has some test tokens in it. I have a custom gas fees. I'll try to increase the limit because I can accommodate larger gas size here. What I'll do is I'll first set up the initial owner, and obviously I'm going to pick my own address for this. Let me pull my address for this. So I just copied my address, paste it here. So with this, I hope my MetaMask is visible. I'll click on
Mm.
confirm.
Oh, okay. I think your screen went off.
Yeah, my screen is off. I'll just
Yeah.
share it again. Back to my remix. And as you can see, there is a deployed contract which has a contract address here. Everything is deployed on the chain without any issues. Okay. I'm going to just copy the contract address. I am going to go on our Explorer, which is pharosscan.xyz. It's also available in the onboarding doc. I'll have shared my screen. I hope it's visible. The Explorer is opening. I'll paste the contract address here and I'm just going to open it. So I'm telling you it's the internet, not the Explorer that is facing the issue because I'm doing
Okay.
multiple things right now. Yeah, I'll just open the address here, the contract address. You see the contract is there live. It has one transaction done, which is contract creation. Now I can do anything that I want with this contract. So this is as easy as it is. Like you can just pick up any open Zeppelin contract, deploy it in Pharos, and start building. You don't even have to worry about hard at Foundry or anything. I didn't do anything crazy. I didn't do anything that will confuse you for the deployment and contract creation. As I told you earlier, it's so easy. Like you don't have to worry about. So this is how we are compatible and easy for builders to build.
Okay. What about adults? Is it also compatible with adults?
Sorry, can you repeat?
Is it also compatible with adults and then Foundry?
Yeah, it's compatible with hard hat, Foundry, and everything. And we have docs for that, and you can go through the docs.pharos.xyz. It has Foundry guides, it has hard hat guides, it even has the guides for Rust and Wasm. So you can also handle the interoperability part as well. Plus, our new docs are going to be live in next 1 or 2 days. So you'll get much more
Okay.
detailed information about everything.
Okay, that makes sense. And that was actually a lot to take in. So first things first is we'll be looking forward to the blog post introducing all the layers and also the new documentation. Because while you were teaching, I was going through documentation as well to kind of like match what you were saying to what we already have in documentation. And I think the one part that still kind of like blows my mind is the 50,000 transactions per second. I feel like that would be a really, really nice game changer for the EVM space. And no, go ahead, go ahead.
So I'm just saying that on DevNet only we have 20k TPS, which is even higher than available blockchains right now. Even Monad, Mega ETH are facing problems to maintain 10k TPS. I mean, Monad hit its testnet, but it's really struggling to keep it up to 10k TPS. With Solana, with very high performance, it's around 6.5k TPS max. It can go
Okay,
a threshold of 6.5 TPS. So we are actually beating everyone in numbers, and you don't require resources for that as well. We are operating on a 16 core CPU with a 2 TB storage for all the validators, which is much more easier to implement for validators. So we are getting a lot of good response from all of our validators where it's easier for them to maintain as a validator, because with less resources there are much more opportunities for them to earn on the network.
yeah, okay, okay. So currently you said it's on currently on DevNet and then we're pretty soon to be on testnet. So on DevNet we already have 20k transaction per second and hopefully we get the same level of performance in testnet. And
So
also,
testnet is going to be much more better. It's going to be around more than 30k TPS. So currently on internal testing, we are able to hit 30k TPS easily, and we are going to take it more than 30k TPS.
yeah, okay. So then one more thing is what about the decentralization? Like I think one of the things people always consider when they say a particular network has 20k transactions per second, they're always like that network is not so decentralized. How about Pharos Network? What can you say about the number of validators currently?
So the concern of centralization occurs at a layer 2 level. As I told
Okay.
you, we are a layer 1 blockchain. We have our own storage, we have our own consensus. So we can scale up to n number of validators. If you see on Cosmos, there is a restriction of 99 active validators. Similarly, on Polkadot, there is a restriction on active number of validators. And on Ethereum, it's very difficult to keep up because earlier it was proof of work. Now they are evolving to proof of stake. So you see, like with these kind of architectures, they actually limit the number of validators. But at Pharos, as I told you, the more number of validators we get, the more decentralized we will be. Plus, we'll increase the performance. So it's
Okay.
actually beneficial for us to be more decentralized. We can't even stay centralized. If we stay centralized,
Oh,
the network will slow down. We want more and more decentralization. So we'll scale with decentralization. So with Trilemma, you can see we are not losing out on decentralization. We are going with scalability and decentralization.
yeah, okay. Centralization, okay, centralization, scalability, and then availability. So basically, what you're telling me is that Pharos Network are solved the blockchain trilemma.
I mean, right now the trilemma is not more about scalability, decentralization, and security. There is one more added component, which is cost. So you see, when we
Yes,
increase the resources for any blockchain, it gets really costly. You see, like
yes,
many validators who are validating Bitcoin, they left the network, and big institutions started validating Bitcoin blockchain. Why did happen?
yes,
Because as an individual, it's really difficult to keep up with the cost that is required. Similarly, with Ethereum, many validators dropped out because it was difficult to maintain as a validator. But at
oh,
Pharos,
okay,
as I told you, it's very light to run a validator node. It's not very that much difficult. So validators can easily set up the network. And this is the response that we have gotten from the validators. But this is not what we are saying. This is what we have got from industry leading validators who have run validators for a lot of big L1, L2s. They are saying that it's much more easier to run a validator node because of our own storage model, which is much more efficient on input output. And they don't have to increase, because for other blockchains, for let's say for other blockchains, it's very difficult to keep up on the storage side. They need 4 TB storage, but we are doing it with 2 TB. So half the size of the storage, half the size of core required, like 32. Some blockchains require 32 core architecture. Currently we are doing it on 16 core. So
Wow,
it's much more easier. Yeah, so it's much more easier for them
that's
to
cool.
handle everything.
Okay, okay, okay. That actually that makes sense. That makes sense. So I think I'm just going to go ahead and look if we have any questions and so like we can get feedback from our audience because this live stream was supposed to be 1 hour and they are currently at 1 hour 2 minutes. Oh sorry, just 1 hour 1 minute. But and thank you again, Janesh. That was a very, very comprehensive session. Even I think I will have to go ahead and watch the live stream all over again to get like a very, very good understanding about it. And one thing I really appreciate about Pharos Network is that it is EVM compatible. So it kind of like it makes the developer experience quite easier. So they don't have to learn a new programming language. And then you also said something about it's being compatible with other programming languages coming. So I think that is really, really cool. So I'm just going to go ahead and look for if I have any more questions. And yeah, I don't think I have any more questions. I think the others are just going to await the publish of the blog. So we can always go back for reference and everything.
Sure,
But
definitely.
yeah, thank you. Oh yeah, one last thing. One last thing. We're supposed to talk about the Ferris Buddha base camp and basically what from the dev parts, from the dev parts. And I think in the last session where we had and it where we had was it? I think it's Aliu, the head of
Yeah,
the ecosystem development. Yes, yes, yes. And he basically pointed out that what Ferris is more interested in was reward assets. So I think that's very, very cool. I don't think I have any more questions on my end. And I don't know if John wants to make any last, should I say, any last comments before we come to the end of the live stream? Okay. Um, hi, John. Do you have any last comments?
Oh no, I don't have anything to add. It was an amazing session with Janesh. I really learned a lot about Pharos Network. Lots of things I didn't know about Pharos Network. I learned them today. It was an amazing session, Janesh.
Okay,
thanks
okay.
a lot.
That actually is actually was a very amazing session, and I really appreciate that. So, yep, we don't have any more questions. So, thank you everyone for staying to the end of this live stream, and also make sure you follow the Ethereum Nigeria community to stay in the loop and also like keep up what we're doing. And also follow Ferris Network. They currently have a builders base camp ongoing and you stand a chance to win up to 300K. Yeah, that's 300K dollars, not Nigerian naira in any way. So 300K dollars. Just go ahead, check the hackathon page, and then after this, I'll be making a tweet and also be including a link to the first Buddha base camp for anyone who wants to participate. And I think that's it on my end. So thank you once again, Janesh, and this was a really amazing session. And also thank you to the first talk team. You guys are amazing.
Thank you for having
Okay.
me.
Okay, okay. I'm just going to do okay, an outro. So thanks once again, everyone, and have a wonderful rest of the day. Okay.